And how long is our class for today?
There one session, 30 minutes, I think.
30. Okay. All right. Fair enough. All right. So you guys know already that we're talking about motion. All right. Last class we started off with distance and displacement. Um, not sure if you guys fully understand what I was teaching, but you know, if there are any persons who have any issues, know it's a good time. See, that we're
Me,
starting.
sir.
Who's me?
Chelsea.
But Jersey, I thought you understood.
I don't understand.
What you don't understand? Tell me.
Us. Sir, I don't understand, sir, because sometimes, like yesterday, sir, when you were looking at the displacement for something for a
Mm.
certain distance, and you said that the distance is 180, but the displacement is 180. And then when you're trying to look at it the next way,
Mm.
how you get 4 for the displacement right there?
All right, let me just see if I can bring back up that thing. I hope it is this. You talking about this question here?
Yes, sir.
So you remember, Chelsea, our class, you have to take the knowledge from the definition of the things that you're finding, right? If you know what is distance, distance is the total number or the total part that you traveled. You understand? Whereas now your displacement is the shortest distance between the starting and the ending point. So you have to be looking at where is my starting point, where is my ending point, and where is my distance between that. That will determine your displacement. Now your distance, as we said, is the total part that you travel. So if you travel from A to B, you need to incorporate that. You need that's one distance that you travel. Then you you move from B to C. That's another distance that you traveled. So you now have to take your meter ruler and measure that distance. Right? To find the total distance traveled, you have to add these two things here. Add the 180 plus the 140, because this is 40 meters here. So then there's another 100 meters in between here, right? Now, in regards to finding the displacement for AC, this is A, which is my starting point, and C, which is right here, which is my ending point. The shortest distance between that is going to be 40. You understand?
Yes, sir.
So that's what we're talking about. Now we're going to
Okay.
do some more problems, right? Just to get a better hand of what is taking place there, so that we are on point. So let's start off with distance. Let me just see if I can make this a little bit bigger. Somebody go ahead and read that for me, please. Starting from reading position. Somebody go ahead and read it now.
When objects start moving, it is useful to be able to describe an object's location. To describe a location, imagine a meter stick is placed next to the object. The meter stick acts like a number line. Objects to the right of the zero have positive positions. Objects to the left of the zero have negative positions.
All right, good. So imagine you have a meter ruler, right? And you set it up just like a number line. Your number line start off with 0, right? So you start off with 0 as your number line. And you would count to the right and get positive numbers. Now to your left would have negative numbers. We can all agree with that. Now, because we're talking about, well, this is talking about distance, right? But if we're talking about displacement, we're going to talk about that differently. But if I wanted to find like the distance or the position of the lightning bolt, this is a lightning bolt, right? From the starting point, which is 0, that is 5 meters, right? So this is the distance that the lightning bolt is away from the starting point, because you know that your ruler starts at 0, right? Now, smiley face or the happy face is 1 meter away from the starting point. So that's just the simple distance that they're talking about. Now, on the other end now, which is the left side, we're talking about this sun is going to attract a negative value from the fact that we're looking at it from the number line standpoint. So the magnitude here is -4, right? So that's simple, you understand? Nothing complicated. All you're doing is you're counting from 0. So from 0 to 1, that is, from 0 to -1, that is -1, -2, -3, -4. Cool? So that is just we just taking positions on a number line using a simple meter ruler, right? Now here is another question. Go ahead, write it down, answer the question, and let's see. All right, think we're finished? Are we done? Talia, are you doing a question?
Third draw the number line. I write in the question, but I don't know if I'm supposed to draw the number.
Yeah, man, draw the number line, man. Anna, are you doing a question? Is it Anastasia? Or Anastasia? Christian, are you doing a question? Christian Anderson, I'm talking to you, sir.
Yes, sir.
Omari Swaby.
Yes, sir.
All right, I'm guessing everybody's doing that question. Don't take forever. We don't have all day today. All right, we have a lot of things to cover. Hey, Mr. Brian.
Yes, sir.
Why are you so silent in my class, man? Huh? Brian, I'm talking to you, sir. Why are you so silent?
Sir, internet access poor. I can't really
Okay,
hear
okay.
again to join on fast.
Okay. I want you to explain that to me. That's all I want you to do. All right. Sorry for your shaky internet, man.
Yes, sir.
By the way, guys, I post the videos on YouTube. You know my YouTube channel already, Ray's Tutoring JA. Just go ahead and access those classroom videos that we created previously. Can go ahead and watch it to Reactor Ring. All right.
Sir, are we just supposed to do numbers 1 to 3?
Yes, yes. For now, yeah. Are we done with that?
Yes, sir.
All right. Now it says, what is the position of the heart?
4, positive 4.
Positive 4 meters. Good. Now, what about the position of diamond?
Negative 4.
Diamond. Oh, yeah, good, yeah. My bad. -4. Good, thanks. Position of the cross.
0.
0 meters. Guys, don't forget to put on the meters. You understand? So that was simple, right? Now, what about this one? It says put an S at 2 meter mark. That is very easy. So go ahead and put S right here. It says, all right, put a D at -6. So you put a D here. And now it says what? Put a K at 7 mark. So K would go here. Then now E at -1 would go here. All right. So that sums up that aspect of what we're talking about in regards to distance. Now, we want to talk some more about displacement, seeing that displacement can be the tricky one, right? And I have the perfect questions here to dissect this aspect. So let's go ahead and I wonder if I had an example for this part first. Oh, this is what talking about seeing position. All right, yeah, this one here is talking about position, which is same thing as distance. Let's go ahead and see if you can determine and answer that question for me.
Which question is that, sir?
Yeah, it says objects often change position. In this activity, find the initial and the final position of the object. So let's look at the diagram here and determine which is the final or what value in terms of distance is the final and what is the initial.
Sir, can I answer?
Go ahead.
Sir, so the initial position of the frog would be at 6 meters, and then the final position would move down to 2 meters.
Now the next question says, if the frog traveled in a straight line from the initial position to the final position, what distance did it travel?
4 meters.
Precisely.
3 meters.
No, not 3, 4. Because this is how we're doing it, right? This is my initial position, right? My initial position is right here. Now let me count how many 1 meter boxes are in between the initial and the final point. So here I have 1 box. So this is 1. Here I have 2 box. Here I have 3. And here I have 4 box that separates me between the initial and the final point, right? So that would tell you that your answer is 4 meters. So do we guys understand that?
Yes, sir.
Yes, sir.
All right. Now moving on to the section D that speaks on displacement. Where's my reader?
Sir,
Go ahead.
um, distance, measurement of the actual path traveled, displacement, the straight line distance between 2 points. If an object travels in one direction in a straight line, distance traveled is equal to the displacement. Often, objects do not travel in straight lines, or they move back and forth, so distance and displacement are not equal. Examples: Bessie the cow and Sally the bird both traveled from point A to point B. Sally traveled in a straight line and Bessie did not.
Good. And it says the question says, what distance does Daisy the cow travel? Look at the question. What distance did Daisy travel? The cow. What distance did it travel?
25 meters.
5 meters. No. What distance did Sally the bird travel?
10 meters.
All right, fair enough. Now, question is, what is the displacement? What is Daisy's the cow's displacement?
10 meters.
10 meters, yeah, but you see the answer on my screen, I know, right? And the same thing would apply for Sally, because Sally is coming from the same position, which is right here, and both of them are going to the same direction, right? Now, we agreed that Sally's distance is 10 meters, right? And at the same time, we just agreed a while ago that Sally's displacement is also 10 meters. This is as a result of Sally traveling in a straight line. As Rihanna read a while ago, that if an object travels in one direction in a straight line, distance traveled is equal to the displacement, right? So what Chelsea was saying this morning, or the issue that she had, right? She said that sometimes you see the distance equal to 180, and then you see the displacement to 180. That is just as a result of it traveling in a straight line, right? I just did that with Daisy with Sally a while ago. Now, here is a question. If the car travels once around the racetrack, what distance does it travel?
100 meters.
100 meters.
100 meters. Good. Now, if the car traveled twice around the racetrack, what distance does it travel?
200 meters.
Good. Now, if the car traveled once around the racetrack, what is its displacement?
100 meters.
No.
0 meters.
0 meters. Remember, if you start here and you go all the way around and you come back to where you started, right? You are 0 displacement. You have reached back to your original position, so you have no displacement at that point, right? Yeah, man.
Sir,
Yes.
sir.
Yes,
So what
sir.
you're saying is that for displacement, as long as you come back to the start.
Hold on. Go ahead. Here.
So
So
it
sir,
has
displacement is
to be in a
whenever you
straight
travel and
line.
end up back at the same point, it would be equal in 0 meters.
Ask the question again, please.
Like for the racetrack, since he started here, and for the third question, he said once travel around, what is the displacement? It would equal in 0 because he come back to the same starting point.
Come back to the same starting point. Yes. So if you had this like almost like a meter ruler, and you had like one, well call this side a negative. I don't know. I was gonna try to think about something. But you know, imagine that this is 0 on your ruler, right? And you traveled 1, 2, 3, 4, 5, 6, 7, whatsoever that be, 8, 9, 10, 11, and you come back right to 0 here. So you understand? That means to say, you know, you are 0. Your displacement has to be 0 because you're 0 meters away from where you started, right?
And you weren't traveling in a straight line.
And you were traveling that straight line. Good, precisely.
Sir, excuse me. Sir,
Yes, ma'am. Go ahead.
I was asking if you could go back to the definition of displacement, please.
So, all right. So there are different definitions, right? In this case, how they define it here, they said that it is the straight line distance between 2 points, right? Now, on another note, we can say that displacement is the shortest distance from the starting point to the ending point in a straight line. Good. So that's that. I hope you got to write what you need to write off. Now, E. Let's talk about what is happening at E. I wonder if I can get this a little bit bigger. Give me another reader.
Me, sir.
I hope your internet is good enough. Go ahead.
Showing displacement. When an object moves, an arrow can be drawn to show the displacement. The arrow points in the direction of motion. The arrow should start non-arrow side.
What happened to you? Your internet boy, your internet chip out.
And at the ending position.
Internet about shaky.
Straight. Examples: a school bus, a bike moving along.
All right, hold on.
Position of 4 people.
Hold on. Yeah, your internet a chip in and chip out. Is it Rashida? Go ahead.
No, sir, that was an accident.
All right, bro. Your internet kind of moving a little bit shaky. But typically, you know, you have a school bus right here, so right. And I said this in last class that whenever you're dealing with vectors, you use an arrow to represent the vector. Good. And that is what is happening here. So from your initial point, this is going to be a tail of the vector. And this is the head of the vector. Right now, the head is going to have the arrow, which will show you the final direction. So this is just simply what it is. Take a rule and draw a straight line to the final position, which is going to tell you the displacement. Right now, a bike moving along a number line, right, from a position of 4 meters to -3 meters. Now, let us try and determine what the displacement of this is going to be. So a bike moving along a number line from a position of 4 meters to -3 meters. What would be the displacement?
-7 meters.
We said -7 meters?
Sir, it would be a 7.
Sir,
Huh?
Yes, sir.
-1. I'm not sure.
1
Negative.
meter?
Negative. Oh, it's 1 meter. Yes, 1 meter. Cause
1 meter, sir.
yes, there's one.
No, it's not 1 meter.
So how you work it out then, sir?
Wouldn't it be 7 meters? Or -7?
I don't understand.
It's going to be -7, right? And the negative sign really is going to show us that it's going to the left, really, right? But let's count the number of spaces that is in between. Because remember, it's the shortest distance between the starting and the ending point. So 1 is going to be here, 2, 3, 4, 5, 6, 7. Right?
Sir, was that correct?
Yes, so it will be 7. And then I would just put the -7 there to show that it's going to the left. All right.
Excuse me, sir, I don't understand that.
So we need to measure the distance between the final and the initial point, right? In order for us to do that, we have to count the individual boxes that is in between them. You understand? To know how much meters it's away from the final point, right? And we'll just go ahead and do that. And we're saying that we're going to make it be -7 meters, because whenever things are going to the left, it's going to attract a negative sign, right? Because the negative sign is going to tell us the direction. See that we're talking about displacement. Displacement are vectors. They must have a magnitude and a direction, right? You could do it in 2 ways. You could say 7 meters, and then you draw an arrow that represents 7 meters. Or you could do it this way that I just did not just now, that by saying -7 meters, and negative would replace this arrow. You understand? All right, let me just bring up this on 1 second. The part here that says calculating displacement, right? I want you to go ahead and look at that part. It says that, remember, displacement is the straight line distance between 2 points. To give a displacement, we should give both the size and the direction. To find the size of the displacement, count the number of spaces from the initial to the final position. We just did that in an example. Then it says, the following shows a displacement of -5 meters.
Sir,
Yes,
so the reason why it's negative because it's moving to the left.
to the left.
Okay, sir, understand that now.
Precisely. And we always say that displacement must have a magnitude, or we call it size as well. So either size, which is the 5 would be the size and the magnitude, right? And then the negative would represent the direction. Let's look at another example before we go. All right, let's look at this one.
here.
This one. It says that use a number line to answer the following question. Now, let me just rewrite this. This is x final.
Do it,
This
sir.
is x initial. So this is your initial point. This is your final point. Go ahead, drop that in your book quickly and answer these questions. They say draw the arrow to represent the displacement, and it says that is the initial position positive or negative? And it says that is the final position positive or negative? Is the displacement positive or negative? And it says what is the displacement? In bracket they say size with units, so you have to write the units that we're talking about. The units in this case is meters. And now for the direction, state the direction, either positive or negative. So do that, take on that question, answer that question. I'm gonna ask you to submit it online.
Sir, can you send me the document, please?
Why?
Because you're already.
Oof, too bad for you, Miss. You're gonna have to write this morning.
So you're not going to send the document?
I wasn't intending to do that. My intention was for you to write stuff very quickly before we end class. Take a screenshot if you may.
Okay, sir.
Sir.
Yes, sir.
Sir, right off the two of them, sir.
No, man, the one that I highlighted, man.
Yes, sir.
So your time up, we can continue. Not gonna post no PE, so.
That's why you love science, man.
But we have PE class.
Well,
Chelsea,
Exactly.
go.
Chelsea, if you want to go, you can go, Chelsea.
Sir, teach the
We have
boys.
PE.
Either way, guys.
Sir, teach the boys.
Either way, I have like a minute and a half left in this session. So once that time cuts off, I won't start a new one. You understand? But go ahead, attempt that question, post it online so that I can see what you did and give you feedback. All right? Now, this is our last class for this week, so enjoy the rest of your weekend and just stay safe.
Same to you, sir.
All right, all right. Are we finished taking out the question?
Excuse
Yes,
me.
sir.
Excuse me.
Yes, sir.
Who said excuse me?
Yes.
Mr. Spence.
Yes, sir. I'm finished.
Hold on, man. Spence, what you say? Talk to me, Spence. Spence, what you
So,
say?
sir, which question is it? Which question is it, sir?
The one that is highlighted, the one that is I marked off with the pink. You know what? I'm going to send it in the group for your benefit, because I know some of you, will.
Okay, sir.
Yeah.
Okay, sir. Thank you.
Yeah, man. All right, guys, take care. Chelsea, don't bother put a belly now, all right?
Yes, sir.
Yeah, man. All right.